oblique triangles, we have seen that you can use sine law to solve for a missing side or angle, but you can only do that if you have a full pair, meaning an angle and its opposite side. But sometimes you don't have a full pair, so there's another law that we can use, which is called the cosine law. So again, remember that all angles are labeled with uppercase letters, and all sides are labeled with lowercase letters, and they are the sides directly across from their angles. So for example, side A is directly across from angle A. Now our cosine law is the following. C squared, which is the side squared, is equal to the other two sides squared, so a squared plus b squared, minus 2 times the other two sides times cos c. Now something I want you to take note of is that this final part is all attached by multiplication. So you cannot just type into your calculator a squared plus b squared minus 2ab, simplify that and multiply it by cos c. This is one unit. You have to multiply the 2 times a times b times cos c, and then that will be subtracted from the a squared plus b squared. Now this first part will look familiar to you because it looks like Pythagorean theorem, but obviously we're not dealing with a right triangle, so we have that additional piece. Now there are two scenarios where you must use cosine law and sine law will not work. The first one is when you have all three sides and absolutely no angles. So if you have something like this, you have a triangle and you're given the three sides but nothing inside, you have to use cosine law. The other one is when you're given two sides and the contained angle. So what that would look like is you have these two sides here and then the little angle that those two sides form. I like to call that the duck or the alligator, just something to remember it by. So let's start off with our first triangle. We have solve for side B. So I will start off by labeling my sides. So across from angle A, side A, here's side B, and side C is across from angle C. Now my goal is to solve for side B. So I'm going to rewrite that cosine law, but instead of starting with C squared, I'm going to start with B squared. And then cosine law says add the other two sides squared. So my other two sides are A and C. So A squared plus C squared. Subtract, usually be 2AB, but here my other two sides are A and C, so 2AC, and then times cos of the angle of that side. So I'm looking for side B, so I'm going to write cos of angle B. What's really important when you're setting up your cosine law is that the side that you're looking for matches the angle with the cos. So now that we've rewritten our cosine law to represent our triangle and what we're looking for, let's sub in some values. So b squared is equal to a squared, so 5 squared, plus c squared, so 4 squared, minus 2 times a times c, and then our angle b is 35. And now we can just simplify the entire right side. So plug it into your calculator all at once. So you should get 8.233918228 in your calculator. And try it out. Try plugging that into your calculator to make sure that you get the same thing. Make sure you're in degree mode. And there it is. Now, we do have to get rid of that exponent of 2, so we're going to square root both sides. And when we do that, we get approximately 2.9 units when we round to 1 decimal. Now notice, in that first step, I wrote down all the decimals I could see. I really do not want to cut down on the decimals. If you have an answer button in your calculator, use it. Okay, take the square root of the answer, and that way you'll keep all of the decimals. And that's it for your cosine law. So let's try the next one. And in the next one, we're looking for angle A. So I'm just going to label side A, side B, and side C. Now because I am looking for angle A, I'm going to make sure my formula starts with a squared, because I noticed in the previous example, when I was looking for b squared, we had cos b. So if I want to find angle A, I have to have cos A in my equation. So I'm going to do a squared equals the other two sides squared minus double the other two sides, and then cos of angle A. So my goal is going to be to isolate for cos A, and we should know that anytime we're trying to find an angle, we're going to have to take the inverse at some point. So let's plug in our given information. So A is 5. So 5 squared equals B is 8, so 8 squared, and C is 6, so 6 squared, minus 2 times 8 times 6, cos A. Now we can start cleaning this up. So I'm going to clean up the 5 squared to get 25, 8 squared is 64, and 6 squared is 36. And then I'm going to do 2 times 8 times 6, and I get 96. But that is attached to cos A through multiplication. So I need to isolate for this cos A, but it's attached to the negative 96, so my goal is to isolate for this as a whole. Now I do see that the 96 is negative, so I'm just going to do a little swap where I bring this to the left, and I'll bring the 25 to the right. So 96 cos A, now it's positive, equals 64 plus 36 subtract 25. And then I'm going to clean up that addition and subtraction. And when I do that, I get 75 and now we're almost there. We just have to divide both sides by 96 so that we get cos A equals 75 over 96. And now you're almost there. We just have to take the cos inverse to actually find our angle. And there it is. Now, how we found this angle, it was a little bit of a tedious way because I used that original cosine law and I rearranged it myself. So why don't we rearrange the cosine law right now? And if you remember this additional formula, you can always use it instead. But if you forget it, you can always rearrange it on the spot. So let's try it out. I'm going to write that generic cosine law. And now I'm going to isolate for cos C. Because if you have cos C isolated for, you can just plug in some numbers, then take the cos inverse, and you're done. So just like what we did in the previous example, I'm going to bring negative 2ab cos C to the left just to make that coefficient positive. And while I do that, I'll bring the c squared to the right. So we have 2ab cos C is equal to a squared plus b squared. Subtract the c squared that we bring to the other side. And now we can divide both sides by 2ab. So cos C is equal to a squared plus b squared, which looks like the Pythagorean theorem, subtract c squared all over 2ab. So if you would like, you can just remember this isolated format along with the original cosine law. And then if you're looking for a side, you want to use this original format. But if you're looking for an angle, you can use this pre-rearranged format, which makes your life a lot easier. But of course, if you don't remember it, you can always use that original one and rearrange on the spot. Now, something I want to make a little note about is that when you're solving for a side, the angle has to match that side. And then the other parts are the opposite two sides. When you're looking for an angle, the side that's being subtracted has to match the angle. And then your other two sides will fill the other spots. That's super, super important because that's the most common mistake when you're solving for an angle. Make sure the side that is subtracted matches the angle that you're looking for. So let's try it out. So here we have triangle XYZ and we're looking for side Y. So I'm going to start off by labeling my sides. So here's side X across from angle X, and here's side Z. So why don't you try to write the cosine law in terms of x, y, z, and then plug in your values and just come back to the video to check your work before you finish off the question. So because we're looking for y, we're going to start with y squared equals the other two sides squared, subtract double the other two sides, cos of y, because we're looking for y. Now let's plug everything in. Y squared equals 9 squared plus 8 squared minus 2 times 9 times 8 cos 25. Now you can jump from here straight to the final answer. So from here, I want you to go to your calculator and type in 9 squared plus 8 squared minus 2 times 9 times 8 times cos 25. And if you press enter, you're going to get 14.4916787. If you want, you can actually write that value in with at least 4 decimals. Now, when you square root your answer, if you have the answer button, click the answer button to bring all the decimals with you. If you don't, use at least 4 decimals the way I wrote it. So now when I square root both sides, hopefully you get approximately 3.8 units. And that's it for the side. Super quick to find a side using cosine law. And this, you can only use the cosine law because you have that little duck configuration where you're given 2 sides and the contained angle. If I were given, let's say, angle x and I have side x, then I would go ahead and use sine law. But this is that duck conformation, so I'm going to use cosine law. Let's go to the next one. I have all 3 sides, no angles, so right away I'm thinking cosine law. And now I am looking for angle P. So I'm going to label my sides. Side P, side M, side N. Now I want you to pause the video and try to set up your cosine law in that rearranged form. So I want it to start with cos P equals. So pause the video, try to set it up, sub in your values, and then come back to the video before you go and plug it into your calculator to make sure you're on the right track. So you should have the other 2 sides squared minus P squared. So the subtraction has to match the angle I'm looking for. So I'm looking for angle P, so I'm subtracting side P squared. And then double the other 2 sides. So when we plug that in, we're going to have 5 squared plus 8 squared minus 7 squared all over 2 times 5 times 8. And if you want, you can plug this all in at once, or you can simplify numerator and denominator separately. So for example, I go to my calculator, and so should you. 5 squared plus 8 squared minus 7 squared is equal to 40 for the numerator. And for the denominator, 2 times 5 times 8 is 80. Don't worry about reducing this because right now we just care about the angle, and we could just take the cos inverse of that 40 over 80. And when you do that, and I hope you're trying it as well, you should get, in this case, exactly 60 degrees. And there it is. So using this rearranged format, it was a lot quicker, but if you make a mistake with that original setup with the side that you're subtracting, you will get it wrong. All right, for the next one, we are looking for side F. So across from angle D is side D, and this is side E. So I want you to try this question all on your own. So write the original equation, set it up, plug it into your calculator, and solve for F, and then come back to the video to check your work. All right, so for the original equation, you should have F squared, because that's what you're looking for, is equal to D squared plus E squared, so the other 2 sides, minus 2 times D times E times cos F. So now when you plug everything in, you should have this set up. And if you plug in that right side, you actually get exactly 43. And when you square root both sides, you should get 6.6. If you set it up correctly and got the right answer, great. If you made a mistake, check to see if it was your calculator work or your original setup. And now let's go to our final one where we are looking for angle H. So here is side H, across from G is side G, and here's side I. So I want you to go ahead and set up your cos H equation, plug in your values, take that cos inverse, and then come back to the video to check your work. All right, so when you set up your cos H formula, you should have had g squared plus I squared for the other two sides, minus h squared. That's super important that it's h squared at the end, and then all over 2 times g times I. So here it is when you plug everything in. If you simplify the numerator and denominator separately, you should get 5 over 4 or 1 over 8. It's the same thing. Then take the cos inverse of your fraction and you should get 83 degrees. If you got it right and you set it up right, well done. If you made a mistake, check to see if it was how you set it up, specifically this minus h squared part, or if it was your calculator. And that's it for your cosine law. So once again, cosine law you only want to use if you're given all 3 sides no angles, and in that scenario you are looking for the angle, which means you want to use that rearranged formula, or you can always use that general cosine law and rearrange it on the spot. That is totally fine. Or you can use cosine law when you're given 2 sides and the contained angle. So pretty much if you don't see that full pair, you can't use sine law. If you do see it, use sine law. But these are the only 2 scenarios where you must use cosine law.